Okay, so today we're doing some statistics review. This one's going to go a little different than what some previous lessons we've been doing have gone. Let me explain. So we're going to review some of the concepts from this unit today. We're going to do mean, median, mode, weighted mean, and trimmed mean. How it's going to work today is I'm going to post the question. I want you to pause the video, try it on your own. So write it down on a piece of loose leaf. And then after you finish it, just unpause the video and then watch as I go over it, right? This way, we're at least gaining some practice at doing this. We're not just watching and listening to me ramble on about what the process is on this. I want you to actually get some practice on this. So anyway, here we go. First question, find the mean of the following data set to the nearest tenth. It gives you a whole bunch of numbers. Pause the video here, and now I'll go over it. So to find the mean, you just have to add up all the numbers and then divide by the total number of numbers in the list. Well, if you add all of these up, you get the idea. You're going to get 86, and then we need to divide that number by the number of numbers in this list, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we need to divide it by 12. 86 divided by 12, if you use your calculator and then round to the nearest tenth, it's going to give you 7.2. So 7.2 would be the mean of that data set. Next question, it's the same data set from before, but this time I want you to find the median. So make sure you find the median to the nearest tenth, pause the video, give it a try. Now I will go over it. In order to find the median, something weird has to happen here. You actually have to list the whole data set in ascending order. So the smallest number I can see in this list is 2, and I like crossing them out as I go just so I keep track of them. Next smallest number is 3. Then I see a 4. I see another 4. Then there's no 5, but I see a 6, and another 6, and then a 7, and then an 8, and then a 9. There's no 10, but then there's an 11, and a 12, and a 14. And just to make sure, there should have been 12 numbers in this list. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're good. We didn't forget anything. I'll just cross out that 14 there. Now to find the median, you have to find the middle in this data set. Well, since there's 12 things in the list, 12 divided by 2 gives you 6, but 6, so 1, 2, 3, 4, 5, 6. 6 isn't exactly, like this is the sixth thing, it's just a coincidence, it's also 6. The sixth thing in the list is not actually the perfect center of the list though, because notice below it, you've got 5 things, and above it, you have 6 things. So that means there's actually 2 middle pieces here. There's the 6th and the 7th piece, which very coincidentally here, again, I did not mean to do this, but very coincidentally, those numbers happen to be also 6 and 7. So since there's 2 pieces in the middle of this list, we can't actually have 2 medians. So what you have to do is you have to find the mean of the 2 medians. So to find the mean of those 2 medians, just add them together, 6 plus 7, which is 13, and then divide it by 2. 13 divided by 2 gives us 6.5. So 6.5, that is the median of that data set. Next question, same data set again. This is the last time we'll look at this, don't worry. Find the mode of this data set. Pause the video. And you can unpause the video now. The mode of the data set is the number that appears most often. It actually might be easier just to flip back and look at our ordered list. Notice we could see in the ordered list we have 2 4s and 2 6s, but no duplicates of anything else. Mode is kind of unique in this regard in that you can actually have more than one mode. So our mode here is going to be 4 and 6. You have 2 different modes on this one. That's totally fine. You can have 2 different modes. You can even have 3 or 4 or 100 different modes if you wanted to. It all depends on the data set. All right, weighted mean. I'll read this one and then you can pause it. In chemistry class, homework is worth 10% of your final grade. Quizzes are worth 20%. Unit exams are worth 30%. And the final exam is worth 40%. Veronica earned 95% on her homework, 82% on her quizzes, 88% on her unit exams, but then only 55% on her final exam. What was her final grade to the nearest whole percent? Pause the video here, and now we'll go over it. Now, with me going over this, I'm actually going to show you a bit of a strategy. It's just a way of organizing your work. I can't remember if I ever did this in the previous videos. I did, and if I did, well, then I apologize for repeating myself. What I do, though, is I like lining things up. So in other words, I'll take her homework grade, 95%, and we have to multiply that by its weighting. Now, the weighting of homework is 10%. So we don't use 10% in math as literally 10%. We actually have to convert that to a decimal. So we'll times that instead by 0.10, which is 10% just written as a decimal. Now we don't change this percent to a decimal because this is the score she received. We could have easily have called this 95 out of 100 or 92 out of 100, etc. These are the actual weightings, though. The weightings are what need to be changed to a decimal. Anyway, the next one she had was her quizzes, 82%. And we got to multiply that by a quiz weighting. Quizzes are weighted at 20%, so we'll times that by 20%. Then we had our unit exams, 88%. Got to times that by what they're worth, which is 30%, so 0.30. And then her final exam, which was a much lower grade than what she'd been getting on everything else, 55% times by the final exams weighting, which is 40%. Now here's what I do with these. You can actually just multiply these straight across and get some numbers, and then we'll have to add those numbers up to find the final grade. Now, if you're not comfortable doing it this way, you could always have just put brackets around all these and then added them all up in your calculator all in one go, and that's just fine. But I like breaking it down to see what each one of these things, whether it was assignments or quizzes or unit exams or the final exams, what they all made up to make our final grade, right? So anyway, I'm going to multiply all these through. So 95 times 0.10 is 9.5. 82 times 0.20 is, got it written down here, 16.4. 88 times 0.30 is actually 26.4. And then 55 times 0.40 gives us 22. To find a final grade, we just have to add all of those things together. I guess I should have really put the plus sign on this side. That kind of makes more sense, doesn't it? Add all of these together. Anyway, I threw that in my calculator. That gave me 73.4, but it does want it to the nearest whole percent. So we got to follow what it's asking, round it to the nearest whole number. Well, that would be 74%. So that would be her final grade in that course. Last question here, trimmed mean. Calculate the trimmed mean of the following annual salaries. I didn't bother giving them names because I couldn't fit names in these boxes, so I just called them letters. This is how much money all these people are making each year. Find the trimmed mean of it. You can pause the video. And now I'll go over it. This one is a little different than the other trim mean questions that, at least that I had showed you. There might have been something in your workbook that you'd seen like this. With trimmed mean, you have to knock out the outliers, right? And the outliers are the numbers that are either way bigger or way smaller than everything else. There's actually two outliers in this case, and they're both on the high end. Notice most of these people are making like some sort of $1,000 a year, right? So $45,000, $27,000, $57,000. Whereas these people, E and G, are making way more than $100,000 per year. These are huge outliers. This person making $515,000 and this person making $416,000. Each of these people separately, I would bet, are probably making more than everyone else in this list combined. And if they're not, it's pretty darn close. I just haven't done the math. Either way, though, these people are outliers, both of them. So we actually should knock both of these out of the list, because otherwise they're going to really ramp up the mean if we were to calculate it the old-fashioned way. But remember, with trim mean, there's something you always have to do. You can't just cross out the outliers. If there's two outliers on the top, you have to knock out the two items on the bottom as well. This keeps it fair. You took off the two big numbers, you have to take off the two small numbers as well. Well, the smallest salaries in this list look like they'd be 27,000, and then the next smallest number would be 33,000. So those two salaries have to go out the window as well. We just have to find the salary, or I mean the mean now of the remaining 6 salaries here. So just add up these remaining ones: 45,000 plus 57,000 plus 48,000 plus 36,000 plus 51,000 plus 42,000. Of course, use a calculator, and then divide it by 6. I did it all in one go. Sorry, I'm not going to show you what the whole full sum was, but I did it all in one go, and I got the mean to be $46,500. That would be a better representation of what the average person, even in the entire list here, would make, because we ignored the bottom outliers. The bottom outliers, this one in the 27,000, and we ignored the top outliers as well. That is why that's useful. So these big numbers don't totally ruin the rest of our entire, our whole data set, right? Anyway, we're done. So for practice, I want you to complete any of the remaining practice problems in your booklet you haven't completed already, but probably more pressing is to finish this homework assignment. Please make sure that's done. Again, if you have any questions, send me an email or contact me over Google Classroom.